and looking at the magnitude and direction. So the first part is we took our vector, we wrote it in our component form. And what's nice about that, though, is to find our magnitude. Magnitude, as you guys can see, oh, we found the magnitude between 2 points. That's using the old distance formula, right? But what's nice about finding the magnitude, first of all, the way that we're going to represent magnitude is by using these kind of double absolute value. That basically represents the magnitude. Okay? So magnitude, you're going to see, is going to look something like this. A general kind of formula when you have it in component form, because technically, do we really need to use the Pythagorean theorem to find distance? No. All we simply need to do is take the square root of v1 squared plus v2 squared. And that's what look at the Pythagorean theorem, or look at the distance formula, and then look at the next one down. It's basically square root of a squared plus b squared, right? And is that basically what I'm doing here? That's the same thing you're doing, right? You're just taking the square root of your length and your width. So in this case, I have the square root of 8 squared plus 4 squared, which is equal to the square root of 64 plus 16s, square root of 80, which we can simplify into what? We'd have 16, so that'd be 4 radical 5. OK, so that is our magnitude, which is the length of our vector. Got it? Feel OK? OK. The next thing is let's find our direction. So again, to understand the kind of direction, the best way I like to look at this is think about the triangle, guys. Even though we're talking about this vector, since it's in component form, we can go with this understanding our understanding of triangles. And if I know that this component from here to here is 8, and this component is 4, I can find the tangent. So the angle of a triangle is equal to v2 over v1. This is for any vector, any vector, v2 over v1, which is really what we're doing is the tangent of opposite over adjacent. That's really what we're doing. So we could say the tangent of theta is equal to 4 over 8. To solve for theta, you say theta equals tangent inverse of 1/2. So just make sure your calculator is in degree mode. You say the answer? 26.57 will round to the nearest thousandth. Well, actually, for my example, I'm going to round to the nearest degree for today. OK? To the nearest thousandth. Oh, for angles, all to the nearest thousandth. But for this lesson, or for what I'm doing, I'm going to round to the nearest degree, 27 degrees. So that's what that degree is right there. Right? But remember kind of what we talked about when, of that triangle. It really kind of depends on where your vector is and which quadrant it is. That affects the angle, right? And we kind of talked about that with the angle that Joseph gave us in there. Well, the angle under the triangle was 56. But I'll talk about something else. But that's not always going to give us our angle as far as in that regard. OK. But does everybody see how I got my angle and my direction? Yes? So you can write down those formulas, and memorize them. But